Today we're going to simplify radical expressions, and to write something in simplest form, that means you have to have no perfect squares under the radicals. So let me write this out. Simplest form means when there is no perfect square other than one under, we'll say n, the radicand. Now, what I mean by radicand, that means under the radical. So, here's your radical symbol. The radicand is your number underneath it. Okay? So, now, before we get into this, let me list out some perfect squares, just so that everybody's familiar with it. So your first perfect square would be 1, and then it would go 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, 169, 196, and then 225. Now those are numbers like 1 squared, 2 squared, 3 squared, all the way down to 15 squared. Now, just to let you know, x squared is a perfect square, x to the 4th is a perfect square, x to the 6th are a perfect square. That's because you have even exponents. Okay? So some example here. Let me list out the steps. To simplify, what you want to do is you want to, number 1, break down radicand to its smallest factors. Okay, now after you break it down to the smallest factors, you're going to group in pairs of 2. Now, for each pair of 2 you have, it's going to be represented once outside. So, each pair will be represented outside once. Every time. Okay, so that's step 3. Step 4. What's not paired up will stay under the radical. So what's not paired will stay under your radical. Okay, so let's do some quick examples here. Okay, so I'm going to slide this up so that we can see our perfect squares and our steps here. So these are our steps. We're going to follow these steps every single time. So, step 1, number 1, let's do 16 because it's a perfect square. So number 1, radical 16. It breaks down to 2 times 2 times 2 times 2. Now, we know that 4 times 4 gives us 2 times 2 and so forth. Now, I'm going to group them. There's one pair, there's a second pair. That means it comes out twice. So it means I have 2 times 2 outside. Well, so my answer is 4. Now, there is no radical because it is a perfect square. Okay, second example. Let's do 75. 75 can be broken down to 3 times 25, and 25 can be broken down to 5 times 5. Now, we have a pair of 5s, so our 5 is going to come on the outside, and the 3 is single, so it has to stay home. So, that's how we simplify radicals. Okay, so let me do one where we are using letters now. let's do x to the third. So x to the third. That means we have 3 x's underneath. 1, 2, 3. We have only one pair of 2, so that means only one x can come out and one has to stay in. So there we go. And one last example so that you guys really get a true understanding of this is if I do 8x to the 5th y squared. Okay, so let's break down 8. 8 is 2 times 2 times 2. Then we have x to the 5th. 1, 2, 3, 4, 5. Then we have y squared. Okay, so we can pair up the y's. So we have one of those. We have one pair of x's and another pair of x's. And then we have a pair of 2's. So we know we're going to have a 2 on the outside. We know we're going to have 2 x's on the outside. We know we're going to have a y on the outside for every single pair we have. Underneath, we have a 2 and we have an x. So this can be written as 2x squared y radical 2x. And that's how you simplify radicals.